Yay, SSPP online class 12, chemistry. Okay. Came in sir Siamkhanthang. Hey. Can topic ding solid state chemistry. Hey. Introduction done in genle solid state chemistry abangting study abangting wam kha chi again talsa bangina solid state ichi banga ma solid state ichi kha matter aya matter. What is matter? Matter is anything that have mass and occupy space. Mass le ni space le occupy, that is called matter. Dan tampia kha matter ina have different stage mana. Okay, paite subang igel zole solid, liquid, gases. Matter has different states: solid, liquid, gases. Class higher study nasim diwa bangai chale state dang khata nomno na, okay, which is called plasma. Plasma at very high temperature, like oxide nisa ichite mo waya. At very high temperature, this state of matter, which is called plasma, exists. Velama extreme level at very low temperature. State of matter is called Bose-Einstein condensate. Einstein, and then condensate. Okay. So matter have 5 states. Okay. The most common one is solid, liquid, gases, and then it Bose-Einstein to plasma. Extreme left or right. Why is that? Solid state chemistry chichanga. Okay. Solid state chemistry chichanga matter laga tungtuang. Solid, study of this solid. The outline thing characteristic of solids detailing differences between crystalline and amorphous solid. Types of crystalline solid, then different types of unit cell, contribution of atoms, number of atoms per unit cell, calculation of atoms in there, detail here. Okay, detail study here. Okay, atomic radius of different types of unit cell on there, density of unit cell, then finally packing efficiency of different types of unit cell. Study di. Okay, amma sa penina characteristic of solids. Yanile. Point karnabang solid have what? Definite mass, volume, and shape. Mana? Hun atom dungzui le mun to atom dungzui solid de na mass yang volume yang shape hek gigi zenzen low. Okay, they maintain what? Definite mass, volume, and shape. Yay, iti point karna. Anina. Okay. Atoms in solid have short intermolecular distances. Short intermolecular distances. You know that? It's something atoms solid atoms te hile. Suppose etigel no atoms ni consider intermolecular distance. Yeah, a center kipan drawn. This distance is called intermolecular distance. Right? D, small d. Bangzia ka short intermolecular distance jiyala. It is because intermolecular distance are have the units what? Picometer. Okay? Picometer. picometer khan ichi in terms of meter how much? 10 to the power minus 12 meter. Okay, centimeter like 10 to the power minus 10 centimeter. Yeah, divided by 100 10 to the power minus centimeter. This is centimeter. Nang ni wa aneu dan lu sim suang to nang ai to dil han. Okay, this is like okay, minus what tum line legend. This is minus. That meaning, okay, this is 1 by 10 to the power 12. What is this? Okay, 1 by 0 som la ni om chin ai. Di nga guk sagi gyat kwa som la khat som la ni. 1 by yaiza som la ni. Okay, yam som yam in terms of meter. Okay, meter abang he declare. Okay, this much meter. Now me will tell no why they have a short intermolecular distance. Okay, picometer. Same thing. Anona. Okay, atoms in solid have what? Strong intermolecular forces. Okay, atoms to atom khat kala solid there is a very strong what intermolecular forces. Point khat nang next point the constituent particle remain fixed at their positions. Yeah, diagram and dule now. Okay. Consider this or this whatever. Okay, last pen now. Okay, consider this. Right? Okay, these particular atoms, okay, most of the time remain fixed at their positions, okay, but they can oscillate. Okay, to and fro, same distance. They oscillate between the mean positions. Mean is a middle position. Okay? So, when the constituent particle remain at their fixed positions. Okay? And only can oscillate about their mean positions. Okay. Next point, solid are incompressible and rigid. Bang chinale, okay? Compressed halo chinale, okay? Solid teha compressed haksa. Aziaka atoms are maintained. Atoms are arranged at regular geometrical pattern. Okay? Ko ayam distance between yai to yai ki kala sauzut to amleom lo ki bang. Okay, there's a regular ordered arrangement of atoms, right? Why is it? They are incompressible. Sepu mokhik lo he chin rigid. I mean ki bang thau they're very rigid. Sepu khek ming lo under pressure khek ming la. Atom na bang they have high density. What is density? Density, mass per unit volume. Unit volume mass. Suppose solid to liquid to gas. Hindi boleh. Yai lani, okay? Yai a box karka. Say unit volume, same unit volume. Okay? Okay. In this same unit volume, how many particles of solid or liquid and gases are there? Solid tampe nahi, diagram alai solid chit mai. Mass per unit volume, liquid and no tom deu, gas atom pen. Why is what? Solid have the highest density among what? Solid liquid gases. Okay. 8 point that you solid okay. One is what? Crystalline solid and the other amorphous solid. Okay. Key features of crystalline and amorphous solid and sunole. Akibat low now. Nature chichu crystalline solids are we call them what? True solid. Solid to akinai property akinai penjagina we call them true solid. Okay. Solid one way. Okay. Amorphous solid. Okay. Amorphous solid atom the arrangement random regular geometry arrangement of those yakina somehow they can they change this shape. Okay? Why is that? They resemble close to the properties of liquid. Okay? Two molecule okay, and we call them what? Super cool liquid. I call solid. Jo tak lawai jaga pseudo solid. Okay? Solid tak law okay? Next point about geometry. Then again, crystalline solids are what? Okay, they have their atoms arranged in a repeating manner. Okay? The atoms are what? Arranged in regular and ordered arrangement. Why is that? Okay, crystalline solid shape very defined, okay? Very defined and definite. Shape would change maybe. Okay? Amorphous solid, atoms are arranged randomly. Why is that? They don't have what? Regular and ordered arrangement. Why is that? Amorphous, okay? Solid shape very irregular. Okay, jangan shape hey. Melting point, you know, a crystalline solid have what? Very sharp melting point. Sharp melting point bang China. Value khat China. Okay. Electron sodium chloride melting point bang zale. Okay. Melting point of sodium chloride is 801 degrees centigrade. Hun tuam I kile koi mun sodium chloride heat legend. Okay. About they will melt at only one value, which is 801 degrees centigrade. Again, just 700 degrees centigrade of melt. Okay. They have one sharp value of melting point. Amorphous solid they huchilo. Okay. Okay. Amorphous solid they melting point ka. Okay. They melt over a range of temperature. It's a melting point of amorphous solid. It melts at what? 1400 to 1600 degrees centigrade. Okay? Degrees centigrade. Value ki jam nahi lo. Yai ki kala mel wahi china hai. Crystalline solid diamond baka. Diamond melting point is 4207 degrees centigrade. Why is it? Sodium chloride and diamond here, they have only one melting point. A cleavage property. Cleavage property. Okay. Crystalline solid. When if you cut with sharp edges, okay, blade okay, any crystalline solid cut you will get product of two new half, okay, with a smooth surface. Okay. Suppose it's something there I cut this is crystalline solid, you cut here. Product will be, okay, you will get two halves. Okay. Yeah, that is called, okay. That is they produce what? Smooth surfaces. Along the amorphous solid cut leuchen, they will produce what? Very irregular surfaces. Suppose you cut here, cut leuchen. Only blip there. As atoms are not arranged in regular manner. Rigidity and all that. Crystalline solids are very rigid. Meaning, okay, even if you apply what mild forces, force ne chicken head khaya bangyam chilo chinle a shape kishing hilori. Amorphous solid tela, they are not rigid. Neochic force neochic yam ina I have to shape zeno. Rigidity what done so there. Heat of fusions. Banga heat of fusions. Thermodynamics. Okay. A substance solid form, a solid state, a liquid state, na convert na heat legend. Whatever energy involved, whatever temperature involved, that is your enthalpy. Okay. So, okay, as expected, crystalline solid in they will have a definite or sharp heat of fusions. Value khat nahi hondi. Amorphous solid they will have again a range of value of heat of fusions. Sharp value of heat of fusion later. Isotropism and nonole. Isotropism. What is isotropy? Again, what is anisotropy? Isotropy phenomena ha. The magnitude of physical properties. Physical properties, say example, what are they? Refractive index, electrical conductivity, thermal conductivity. Suppose in a crystalline solid, suppose Neihsial. Yeah, alien has chloride, anisopian sodium. Okay, this is your Cl minus. This small one is Na plasma. Crystalline solid atom arrangement it is very ordered. Alien, chloride, sodium, chloride, sodium, chloride, sodium, chloride, sodium, sodium, chloride, sodium, chloride, sodium. Crystalline solid, suppose, okay, in different directions cut kon dia. Suppose this direction. I'll call it AB. Refractive index value. Example in Ladia, refractive index value. You know, a refractive index along AB. Bangza, I'll take another directions. AB, CD directions to amkhat banonole. CD. Bangza, okay. Enole. Suppose, yeah, direction khat kon lan only A, B, C, D, E, F. Okay, along different directions. Along different directions. Okay, this is refractive index along EF. A value to ame. Suppose this is 1.4, 1.5, 1.6. Right? So, what is anisotropy? Okay, along different directions, the physical property of crystalline solids have different values. Why anisotropy? Direction ang tuam le physical property te value tuam. Why to anisotropy? And which bang substance take anisotropic? Yeah, amorphous enole. Amorphous is it is isotropic in nature. Isotropic and non-nule. Then again anisotropy. Amorphous te structure very random and haphazard arrangement. Okay, zui tumta da nomlo. It's a amorphous solid. Okay, atom arrangement hitale. Yeah, direction khat kon lan on dia. So khadi AB directions. Direction khat kon dia CD AB CD. Why a pen kon lan on dia suppose ABCD EF. Yeah, value like refractive index along what? AB. Refractive index along CD. Refractive index along EF. A value kibang amorphous a value kibang bokahi. So isotropy bangale it's a phenomena. It is a phenomena where what physical property is same along different directions. Direction tuam physical property value ka kibang vek. Okay? XII refractive index ila adang dang le lakti champion so anisotropic chichu direction tuama value tuang isotropic akila isotropy chichu in different directions a value ki bangvek ya i table form oma so pose lang points ni gel siya lang crystalline to amorphous solid ki parlona pose di not ina gel siya abana there are 4 different types of crystalline solid ya teka tami siang lo pide ya poimo lokal kewa okay thei mai di okay molecular solid network solid ionic solid and metallic solid solid te kichen son na ya subtypes enale na okay amorphous solid helama crystalline solid noya ya dena again teng ya liteng yeteng okay liteng oma okay covalent okay network kele okay metallic ionic molecular ya vela yetele kichen son suglai yela taglama yele kichen son suglai yete ka textbook study di ma different types of unit cell ichi banga the smallest repeating unit which make the solid crystal which represent the whole solid crystal lattice ma yai bang bang unit cell tamo velam taklam x and y direction z directions 3 dimensional okay the smallest repeating unit that repeats and extend along the whole crystal that is your unit cell ai le unit cell chi tuam oma akhat na simple cubic cell abbreviated form SCC ichi dia yai simple cubic cell corner giatom katni thumli ngaguk sai giat eka simple cubic anina face center cubic cell abbreviated form FCC structure ka yedani amasa simple cubic drama sadin simple cubic corner giat yai face dia ya center khat ko le ekha face khat yai ina ya ko le this is face ni face center thum li gukom ding ma gukom te yakha corner giatam amasa FCC bang simple cubic tunga FCC ki bola izakina corner giat bana face gukom athumna body center cubic cell oma BCC structure है ये दाने
unit cell draw masagi geding unit cell draw body center ya alai jang taka atom khat koi de ekha BCC structure corner giatom body center khat no Alina type of unit cell Lina and center cubic cell structure ये दाने unit cell ya atunga face consider di face center khat koi anwai face le consider non di face center ka the face te gel chok consider di on the top of what simple cubic cell was jakina corner gyat me ECC plus 2 face center Maban son mauna yai unit cell te parameters hen khat gen cheng ngai oma unit cell like simple cubic structure draw masale so igen sabangena corner giatom khat ni thum li nga guk sai giat corners here kipan hai atom khara kipan atom dang wai line ka its length corner giatom its length som lani wai te chu bang bang simole khat ni thum li nga guk sagi ito he gyat kwa som khat ya age mulahin ya som lani its length som lani kine ito kizoiton na at center kichi khatom nanda why chu at kata midpoint at center kichi wale somleni nai at slang somleni le chu at center le somleni nai simni khat ni at thumna a center ga thum at lina li nga group at center midpoint sagi gyat kwa som lekhat som lani so som lani ma waicha no na faces ma gukom ding waita chu ko bang bang yanen la face khat side apa ya pa sungai ni face ni thum li yai ke lama na uya anung lama guk so face guk okay face center kichi no na face gukom na chu face center le gukom din face te face gukom then is again bangina okay face te lai tak atom khat collection face center right face center gukom de khat ni thum li nga guk guk why no na body center ki chom na then again sa okay alai tak ko ma su khalo body center khatam why no na face diagonal ki chi khatam ha why to face khat selection na a corner to okay, one corner and the other corner join let's diagonally face diagonal ano na body diagonal kichi am na simple cubic as a whole in consider la a corner to la corner pen connect let's this is your body diagonal isin nonding okay thei de hoi mama bangsa hem yen non de okay unit cell diagram drawn on the Enole. Here ya. Corner tom khat. Unit cell bang zaina. Okay. Kiser kha. Okay. Sukha. Ji. Calculate jole. Ye unit cell khatam the ya. Mana? Ya unit cell le, unit cell le, ye particular one corner atom it touches ma sukha. Adang lah om the unit cell dangin sukha the om chances the khatom mana. Right? Adang lah, ya no la khatom the la. Ma. Okay. Li hita chứ yai block kha yai corner atom is touched by how many shared by 4 unit cell ai le ya next block akila tunga bang za om thei di yai bang li om thei lai mala yai tunga mala yai tungge ya yai bang li om thei lai so Africa ki goma yai corner atom sukha unit cell bangzao me chi le gyat mane 8 atoms so anole contribution of one corner atom bangsa unit cell gyat ina kisero wala so 1 by 8 unit cell gyat laga ma contribution atom khat ki consider china 1 by 8 right ai le unit cell just in one unit cell 8 corners lakini no so therefore what contribution of 8 corners atoms bang 8 into 1 by 8 this is 8 into 1 by 8 This is contribution of 8 corners atom. This one is contribution of one single atom. This is contribution of 8 corners atoms. Now, contribution of one phase center. Calculate non le diagram drawn on the phase cut consider le unit cell bangzaina yai atom phase center atom aki CRP wala ni choe unit cell dang leom hile mau kha yai atom sukha lo himi mo yalam leom sukha non lo himi why is zakina yai phase center khat a particular phase center is shared by only 2 unit cell. So unit cells are here annoy geldi. So this is 1. This is contribution of one phase center. But we have how many phase center? 6 in total. Contribution of 6 phase centers. 6 into 1 by 2. 6 into 1 by 2. It is 3. Good. I'll next. Consider only this unit cell. Now, H. Calculate the contribution of H center. We calculate only one. Diagram done. You draw the one. H. Consider the unit cell bangza ina yai H land ki CRP wa mana andan su ya unit cell khatam the good H khathita adang le yale khatin le su khathe ya adang chance on laya ya khatam the lai khat okay. Yai H, this particular H length, H center, H length is shared by, touches by maximum 4 unit cells. Okay. Contribution of one H center, and while I'm a 4 gildi at 1 by 4. But we have how many H center? 12. Contribution of 12 H center, 12 into 1 by 4. It is 3. Yeah. Contribution of body center. Bangsa idi himim. Ya lion pen. Ama kuama to kisukalo is yakina. Contribution of one body center will be 1. Contribution of one body center is 1. So as in the number of atoms atoms per unit cell. Okay. Number of atoms per unit cell. First, SCC, full form conjunction kide SCC. Simple cubic cell. Simple cubic cell. Bangsa a diagram draw le ang changa draw zeldi wa at ni thum corners gyatom and corner te atom contribution 1 by 8 then he sang so this is 8 and 8 cancel so 1 why is yakina SCC number of atoms is equal to 1. BCC ni le. Ye ma tak ya? Ya zangnya. Tuan lihat mana? BCC alaya body center khatam. So corners take contribution here 8 plus contribution of one body center. This is 1 plus 2. So in BCC there are 2 atoms. 2 atoms. 3 na FCC. So good. Corners take contribution here plus face group kine face khatina contribution 1 by 2. 4. So in FCC, number of atoms is 4. Abana simding atomic radius for different types of unit cell, different types of unit cells, SCC, BCC, FCC. Yating thuma atomic radius calculate di mah. Atomic radius is R value, right? Atomic radius is R value. No? Okay, akhad na din na SCC consider nila. So SCC atomic radius. Diagram drawn on the simple cubic cell. Ano lah? Atoms are represented by a sphere. Represented by sphere. S-P-H-E-R-E. Which is sphere lem. Okay, atom ni consider di one. And this H length is 1, A. H length will be A, everything is A. A atom will be represented by a sphere. One sphere, blackboard, paper in 2 dimensions, it looks like circle, but actually it's not circle. Size ki bang di, so ye kong lian lo size ki bang. Okay, size tigal ki. The center of sphere ke pad ye circumference one radius from here to here is another radius, which is A is equal to R plus R. A is equal to R 2R. Therefore, what happened? R is what? A by 2. Why is it? Okay, atomic radius for SCC is A by 2. Atomic radius for BCC, calculate non dia. BCC. Ano lah? Alaya atom khatom ni ma body center. Eno lena ya kha atom thum consider dia, ye consider D, ye consider D, ye consider D. Why kha sphere represent non den denada na that is ya sphere ni ya let's call this as A, B, C, D. A to C le join ni. A to B le A to D le join di. And all the center ki path has 1 R, from here to another center R, from here to here another center R, from here to R. Okay? AD is 4R. Chicken ole. A C length kithelo. A B thesa H lengths are all A. B C le A C kithelo. So in triangle ABC. Triangle ABC using Pythagoras Theorem. Okay. Anina atomic radius for BCC, calculate diwa. Body center ya khatam. Yai atom to he to yai. Ye teng tum consider diwa. So okay. Atoms dekha sphere represent nahi dungzuina gel non diwa. Eno lena okay. Center of the sphere. From center of the sphere, this distance is R. Le yakipan hetan R dangkhat le R yakipan hetan le R. Dekha A B C D. A C le join de. H length it is A ngane. CD le A, BC A, A थे value BC ले थे AB थे BC थे CD थे AC थे लो and then so in triangle ABC using Pythagoras theorem को एक जंगल है right angle triangle is this B angle is 90 I lay yeah B angle like 90 ahi ngai ye kha ale miguel cha 90 banglo hi le ataka 90 hi in a box khat na bol cube khat cuboid cube koilo and en le chen yang angle na cham te 90 hi chap de hi why again Pythagoras theorem ki jang thei ma enola and Pythagoras theorem we know okay hypotenuse square sides open is equal to sum of the square of the base and the perpendiculars. So AB square plus BC square. No. And all AC thelo no. AC square is equal to what? AB whole square plus BC square. Okay. A length is A, BC is A square. Okay. AC is what? Square root of this 2A square. Square root homzak. Okay. ये तो ये cancel, so root 2A. AC is root 2A. A length root 2A. Good. I lay. Okay. ये angle है 90 ही ना angle C is 90. But the Pythagoras theorems are known थे. So in triangle ACD using Pythagoras theorem AD square so open hypotenuse square is equal to AC square plus CD square. Triangle ACD का ये दाने ACD. CD length किथे AC length root 2A ये लेके थे इतना. So AD is we'll find out. AD ले थे okay. How many R? 4R. 4R AD. मुझे R calculate थी यहाँ पे तो ले line खट गया था AD is how much 4R whole square AC थे root 2A square CD is A square yeah यहाँ पे तो ले 4R 16R square root 2 whole square A square plus A square ये तो ये cancel 2A square plus A square so this whole thing is 3A square 16R square R square 3 by 16 A square for my R is square root of 16 A square root 3 and while this can be written as 4 square A square no okay cancel the root 3 yeah. So finally what equal to root 3 by 4 A why is Zakina okay R is equal to root 3 by 4 A जानते दी है no okay. So atomic radius for BCC is root 3 by 4 A face cut so consider ni face center cut yeah tunga pen na ye tung pen so consider dia Yai kha so ya on la khilechin yai dan hai male ki bang hai okay ama salama hi bangena atom thum consider non ding khat atom te sphere ke represent ma A B C A B length is A B C le A C bangza 4R hinon R ma ya kipanetan R ya another R it's 90 degree okay. Pythagoras Theorem jangnole triangle ABC using Pythagoras Theorem AC square equal to AB square plus BC square. AC is 4R, AB is A, BC is A. 16R square, element 2A square. R square is what? 2 by 16 A square. Right here? R is what? Square root of 2 16 A square. Divide all 2 1 is 2 2 8 are 6. Okay. Atung lama A square anoy lama 8 the square root. Square root homza ko 8 ha 2 to power 3 ya. This is 8. You can put in this form. Square root R. Come here. R is equal to ये तो ये cancel A तुम लम्बे ये okay ये ले हम जाते लाए 2 square into root 2 तो square root kan A by 2 root 2 okay. Atomic radius for FCC is A2 root 2. Okay, finally, R for FCC is A2 root 2. Siapa tadi? Itu. Next topic, packing efficiency. Packing efficiency in different type of unit cell. Right, so SCC, BCC, FCC calculate zone, yeah. Packing efficiency. A definition yeah. Packing efficiency is equal to number of atoms per unit cell. Then I calculate the SCC ya bangsa khad, BCC ni, FCC li. Number of atoms per unit cell zeta kiri represent ma. Ano volume, okay, volume of atom chiju, okay, we represent them by sphere ma. Volume of a sphere okay. SPHERE divided by volume of unit cell. Yai packing deficiency percentage on pi days again 100 right? Tom cik zola. Ela kat di kong paso. Hello, nunia. Oi. Om di. Oh, ole. Okay. Ole. Yeah, continue on there. Yan wala. Yay calculation nai hi thei diu khen khat de nai hi banga. Okay. Number of atoms per unit cell. Z value ha. Z value for SCC bangza khat. BCC bangza ni. FCC li. Ete chamte di wana yay volume of unit cell. Okay. Volume of unit cell bang. Yeah, cuboid vale. Okay. Its length A, length is A, breadth also is A, height also is A. Vale. What is that? Length into breadth into height. So all are A. A thum china. Okay. A thum zade. This is I take depends on the system. Volume of a sphere, we know. Volume of a sphere 4 by 3 pi r cube. 4 by 3 pi r cube. R ngom non. Atomic radius. Then I calculate hitchet R for SCC. A by 2. R for BCC. Root 3 by 4. A. R for FCC. A by 2 root 2. Ete khazab di ma. Packing efficiency SCC calculate masani le khatna. Okay. Packing efficiency for SCC. Number of atoms per unit cell khat. Okay. Volume of unit sphere 4 by 3. 4 by 3 pi. Pi is again R pi r cube. R is what? How much? A by 2. A by 2 cube. 100 on the divided by A cube. Okay. Yeah. 4 line P no yang pi is 22 by 7. Okay. Yatung lama A3 anoy lam le 2 to the power 3 2 thum di. Elama anoy A3 100. A3 cancel. 2 11 2 or 4 2. Okay. 11 into 100 is 1100. 1100 divided by 3721. Yeah, divide okay, you will get 52.4%. So packing efficiency in simple cubic is 52%. Packing efficiency banga hai chile. How efficient is the simple cubic system? Efficiency. Here is a space ki occupied china. 52.4% is occupied of space is occupied by atoms in SCC. Empty space. Okay. Empty space is bangza space vacant la. Zatlo amaya. Percentage is 100. Zalaka so 52.4 minus leuchin. This is okay, 6 I am there, point 47. Okay. 47.6% is empty. Zatlo. Chile to SCC efficient low. Anina packing efficiency for BCC. Okay. BCC calculate machine here. So packing efficiency for BCC. Okay. Z value bangita dele. Number of atoms per unit cell for this is 2. Okay. 4 by 3 pi R value like koi pa dia. R for BCC is this, root 3 by 4 A cube pi r cube into 100 divided by A cube calculate le. Okay. 2 line P1 22 by 7 pi root 3 thumve root 3 into 3 times. Okay, 4 le thumve 4 into 3 ni thum 100 anoi lama a cube ya a cube lai tunga. Okay, a cube to a cube cancel. Okay, 4 to 4 2 into 2 2 into 11. Okay. Yeah, 3 lai. Okay. 3 chi bangale 3 is equal to root 3 ni ve china. So yeah, 3 to yeah root 3 tele cancel thing. Bangja root 3 whole square is 3. So 3 is equal to 3. Cancel thing. Okay. Adang thing root 3 value lai the sa okay 1.732 into 100 he pay divide anoi la thing to he leo chin. Namu diu chu 68%. 68% is the packing efficiency for BCC. Is efficient. I empty space calculate the empty space for BCC. 100 minus 68. Okay, so 2. So 32% is empty. It's far better than SCC. Packing efficiency for FCC. Packing efficiency for FCC. A formula enthago number of atom per unit cell in FCC is 4. Very good. 4 by 3 pi r. Atomic radius for FCC bangsa a to root 2 whole cube divided by a cube into 100. 4 into line P 4 by 3 pi 22 by 7. Yeah, a thum ve khat ni thum a thum what 2 root y 2 3 le pai so di 2 thum ve root 2 len thum ve root 2 into root 2 thum ve into 100. 100 check yeah. Okay, and while I'm a cube lai a cube cancel the thing he should left in root bukoyama root 2 poimonala 1.414. Okay, he should left in the module to 74%. Okay, 74% of efficiency for FCC. Okay. Empty space is 100 minus 74. Empty space is 100 minus 74. Okay, bangsa so good. So 26. 16. Okay, yeah, done. Why is again FCC is most efficient? Okay, among the three. Atom na dia he do okay density of unit cell is all there. Density of unit cell. Okay. Density chi bang. It is given by rho. Density, normal density definition is mass per unit volume. But we are dealing with what? Unit cell. Okay. What is that? Rho of what? Unit cell. Okay. Mass of what? Unit cell. Okay. Volume of what? Unit cell. Right? Okay. Good. Okay. Hitchin he will. Okay. So mass of unit cell. Okay. Mass of unit cell will be mass of unit cell, chichu, mass of atom that is present in that unit cell. Mass of unit cell is mass of atoms present in that unit cell. Present in the unit cell, yes. Okay? Let mass of one atom is represented by small m. Mass of Z atom, because we have that Z amount of atom in its case to CC of BCC and FCC. Z. Mass of Z atom will be multiplied here Z into M. Z atom this is also you can write mass of unit cell. Okay, unit cell is equal to Zm. Zm. Equation 1 is diwa. So equation 1 khai chigyal theta ke. Rho of unit cell equal to mass of unit cell hita ngale na tunga ki bangge mass of unit cell is what Z into M divided by volume of unit cell. It is a volume of unit cell is A cube. A cube. And what bultung lama again bang this atomic distance. Atomic distance are in picometer, right? Picometer. Yay A kha picometer convert ngai. Picometer. In terms of meter is this. In terms of centimeter is this. Centimeter hi ni ma. Okay. Why is jakina? A thum. Changa banglo di 10 to the power minus 10 ngen hiwa thum china mana 3 times of 10 to the power 10. So basically this is what the volume of unit cell is A cube into 10 to the minus 10 3 or 30 minus 30 centimeter cube. Ele adik zoi gel udle A cube into 10 to the power minus 30 centimeter cube. Okay. Wajah I and why lama I neuchik one mole is what? 1 mole is can be represented by big M, capital M. This is called molar mass. What is molar mass? Molecular mass expressed in gram is your mole. 1 mole. 1 mole consists of this much Avogadro numbers of atom, 6.022 into 10 to the power 23 atoms. Okay, which is equal to M. Right? Unitary method for calculate for one atom khada. Okay, it's M by Avogadro number tengtengnya anu yang paisuk di 0.22 into 10 to the power 23 atoms. Mass of this is all mass of mass of 1 mole is this mass of 1 atom. Then it's represented by small m. Mass of 1 atom is small m. It's given by this m by Avogadro number. It's a symbol Na and subscript A. Is m value equation 1. So equation 1 becomes Z into small m here, Z into small m is again m tangina small m time this one. And why A cube into 10 to the power minus 3 cube. Finally, rho is equal to Zm A cube into 10 to the power 3 or 30. This is 30. Na. Okay. Density of unit cell finally is this. Okay. Equation him na gelcha yai term khin kharna explain dioma. What is Z? Small number of atoms per unit cell. Atoms per unit cell. M is molar mass. Molar mass. A cube theta. Okay. This is the volume of unit cell. Okay. Na is what? Avogadro number. Avogadro's number. Okay. What is again? Rho. Okay. Density of unit cell. Okay. by heart there. Zm divided by this a cube into 10 power minus 30. This is 30 into na. By heart there now te. Ole. Class 8 ni dia. Pergi pakai.